we're going to look at the position time and velocity time graphs for objects that are thrown straight up into the air. So first, for a PT graph, why don't we draw a scenario of what's going on here? So here is a person who is happy doing physics, and this person is going to throw an object up and it's going to come straight back down. We always want to give some sort of point to be the relative starting spot. And so in the case here, that relative starting spot is going to be the hand. And then it goes up and it comes back down to the hand. Now, in this level of physics, we are always going to assume that it's going to land at roughly the same spot that it was launched. So a case like this, where it's from a hand, or if we had, say, another person who, there we go, was kicking some object or somehow kicked it, like I know there's some of those soccer tricks where you put your toe underneath and then it goes up and it comes straight back down. Okay. So situations like that where it's ground to ground. If we were to look at a position time graph, if the ground or the hand or whatever is, say, 0, right? And then we're going upward, up means positive. And so all of our PT graphs are going to be in the positive area. So positive positions. As time is going forward, the object is going up and then coming back down. Well, honestly, the position time graph for this looks very similar to what the motion looks like. The only thing you've got to do is just take this and stretch it out in time. And so the position time is going to look like a parabola. Now, what does this mean in terms of position time graphs that we've been talking about, in previous units and such? Well, on the way up, it is getting shallower. So shallower means slower. So as it's going up, it's getting slower. Well, we assume that because what goes up must come down. Up here at the very top, it's perfectly flat or horizontal. This is at the highest point. And if it is horizontal, that means velocity is 0. It's not going anywhere. This is also called our max height. Then, as it comes back down, it gets steeper. And so, steeper means faster. So what this parabola tells us is that it's going to slow down. Let me make sure my colors match here, right? It's going to slow down on the way up. Then it's going to hit 0 at the top. And then it's going to speed back up on the way back down. And that's exactly what we expect to see. All right, so now what happens if we look at velocity time? So why don't we write what we know happens? So going up. Going up means a positive velocity. So this needs to be in positive velocity space. What happens as it goes up is it slows down. Then it reaches max height. And at max height, we know that it has a velocity of 0. Then it starts going down. Well, down means negative velocities. And as it goes down, it is speeding up, getting faster. All right, here we go. We need positive velocity space and negative velocity space. Therefore, our 0 is going to be here in the middle. There's time, and here's velocity. These are positive velocities, and these are negative velocities. Well, let's do the green. Green says that we start with some sort of positive velocity, say up here, and it slows down as it's going up. So if it's slowing down, then that means it's going to go towards 0. So this is slowing down while it is moving up. That's why it is positive velocities. Then at the maximum height, we reach a velocity of 0. So this is max height. Then, as it's going back down, down means negative velocities, and it's speeding up. So that means it's going to go from 0 to larger negative values. So let's add that on. And so what we discover about the velocity time graph for an object that's being thrown up in the air, even though the position time graph is a perfect parabola, the velocity time is a single straight line that starts in the positive, hits 0, and then goes into the negative. Something else that we had learned is about the slope of a velocity time graph. So the slope is equal to the change in position, so change in position over a certain amount of time. That is acceleration. So the slope of this line, just like with a dropped object, is still the acceleration. Well, it's a single straight line, which means it is a constant acceleration. That acceleration is g, which is negative 9.8 meters per second squared.